Today we're going to look at rate problems. We've kind of looked at this before as an application of the definite integral, but the College Boards several years ago thought, people don't understand this well enough, so we're going to up the ante a little bit. And one of the things that happens on these is a lot of times you have two different rates going on at the same time. Frequently, one is adding to the pile of whatever it is that you have, people in the building, oil in an oil slick, whatever, and then you have something else that's taking it out. Okay, so you have two different competing rates, birth rate, death rate, those kinds of things that are both affecting some total of something. So let's take a look at this one. The store is having a 12-hour sale. And these are, by the way, all AP problems that I have found, that were released exams. The total number of shoppers who have entered the stores T hours after the sale begins is modeled by the function S, defined by S of T equals to this quartic function for a time between 0 and 12. T equals 0 when the sale begins. There are no shoppers in the store. I kind of like this one better. There's another one, and I think I did some of this with my AB class the other day, where there was an amusement park that you could go into. And it said when they opened, there were no people in the park. And I'm like, I think you mean no guests in the park. I imagine there were people in the park when they opened the gates. But anyway, so it says, at what rate are shoppers entering the store 3 hours after the start of the sale? Well, the interesting part about this is that they're going to define S of T, and that is, in this case, the total number of shoppers who have entered the store. Sometimes they'll give you something like that, and they'll give you the rate at which they enter the store. So you have to be really careful when you're reading this. This is the total number of shoppers who have entered the store. So what do we need to do to find the rate at which the shoppers are entering the store 3 hours after the start of the sale? Yeah, we just need to know what is S prime of 3. And if I remember correctly, yeah, when I'm looking at part C, I'm like, yeah. I'm pretty sure this isn't going to be a non-calculator. Although you can do this without a calculator, it lets you use your calculator for it. On problems like this, where you have a given function and you even suspect slightly that you're going to use it in more than one part, it's to your advantage to go ahead and put it into your calculator before you get too far into it. And although I could take this derivative by hand, I don't have to. Right? That's one of the 4 things that they say, yeah, you can use your calculator for that all you like. And you go, oh, thank you. So I'm going to clear anything else that's in there out. And I'm going to 0.5 x to the 4th. Remember to take it off the exponent. I'm bad about not doing that. 16x cubed, take it off the exponent, plus 144x squared. I'm going to quit out of that, and I'm going to do a math 8, which is the numeric derivative with respect to x of, if I do alpha trace, I can get y1, and I don't have to do that all again, evaluated at 3. And I would say that that's 486, right? And although they didn't ask for units, I'm going to put it, shoppers per hour. God bless you. So let's look at this one. Find the value of 1/3 of the integral from 6 to 9 of s prime of t dt. Using correct units, explain the meaning of this in the context of the problem. You're like, okay. So notice my interval from 6 to 9 is 3, and I'm dividing this by 3. What are you doing when you take the integral of any function? Ignore the fact that this says s prime of t for the moment, but if I just have the integral from a to b of f of x dx over b minus a, what is that?
Average rate of change?
Nope. Average rate of change is f of b minus f of a over b minus a. It is an average, though.
Average value
Of?
S of t.
Well, here it's no.
S of t?
It's the average value of s prime of t. And s prime of t is the rate of change. So this one tied people into all kinds of knots. Because they were like, if you're asking for the average rate of change, why didn't you just come out and say it? Well, this actually ends up being, this whole thing ends up being the average rate of change. This is the average value of the function. Right? But if your function is a rate of change, you're getting the average rate of change. So it says, find the value of this. Well, this value is going to, by the fundamental theorem, be s of 9 minus s of 6 over 3. So again, I'm going to use my calculator to do that so that I don't have to do this by hand. So I want it to be a fraction. So I'm going to do evaluate y1 at 9 minus evaluate y1 at 6 and then divide that by 3. And it's 301.5. This is the average rate of change of the total number of shoppers who have entered the store. And I tell this to my stat students all the time. Parrot what they say when you're not sure how to say it. Just use the words that they use. Of the total number of shoppers you drew an arrow, didn't you? In the store. I knew as soon as I saw your hand moving like that, I was like, you just drew an arrow. From t is equal to 6 to t is equal to 9. And what's the one part I've left off at this point? What's the one thing I haven't done? Haven't talked about the units at all. In shoppers per hour. And here's where we get into the second rate. The rate at which shoppers leave the store, measured in shoppers per hour, is measured by the function L, defined by L of t is equal to this horrible looking function between 0 and 12. According to the model, how many shoppers are in the store at the end of the sale, that is time t equals 12. All right. So this one is a little different than a lot of times you're given two rates. Here you're given an actual value and a rate. So the total number of shoppers that have entered the store is going to be S of 12. Right? Because S is the total number of shoppers who have entered the store. I'm going to have to subtract from that. Now, L of t is not how many shoppers have entered the store, is it? It's the rate at which they're leaving. So I'm going to have to, and since I have a rate, if I want the difference, I need to take the integral. I want the difference in, I want, what is the displacement? What is the change? So I'm going to do the integral from 0 to 12 of L of t dt. Now, I sneak a peek down at this next part, and I'm like, I think I'm going to have to use L of t again, so I'm going to put it in y2. Again, I'd like to not have to type it more than once. So L of t is 4,400. Oh yeah, was there something in front of it? Oh yeah, there was. Negative 80 plus 4,400 over t squared minus 14t plus 55. I want to know who comes up with these functions and how they do it, because you have to be really careful, because if you can make things that it's like, well, that doesn't actually work. You actually have negative people leaving the store at this time, or all kinds of stuff like that. Okay, so I'm going to quit out of that now. And now I can just do this calculation pretty quickly and easily. I've got y1 at 12 minus the integral from 0 to 12 of y2 dx, which is what we have written here, right? Don't write the calculator speak. Occasionally I'll see a student do that. I haven't seen it in a while, but every now and then someone tries to do calculator speak for their calculus. This needs to be calculator speak, not calculator speak, if you see what I mean. And it says, give your answer to the nearest whole number. So there's 196 people. Notice this is the number of people in the store, right? So the next part then, and this frequently happens where one part kind of helps build on another part. Not always. Sometimes you get down to part D and it has nothing to do with anything that came before it. But in this case, it does. Using the given models, find the time between 0 and 12 at which the number of shoppers in the store is the greatest. Justify your answer. All right, so how do we find when the number of people is greatest? Well, how do we find when any function is the greatest?
The derivative changes signs.
From,
0 to 12.
oh, no, when it changes sign from what to what?
From positive to negative.
Yeah, now that's going to get you a local maximum. How do I know it's the absolute maximum?
Find the critical points.
Yeah, and the, dragging it out of him slowly but surely. You can help. And the endpoints. And test them all.
Yeah.
Right? Remember, that's the candidates test. All right, so what I want then is I want to take the derivative of this thing, kind of. I don't really care about the 12, right? S of 12 is a number. This is all numbers. But I want to take the derivative of this. So I want to know, when is S prime of t minus, what is the derivative of this thing going to be? Well, the derivative of the integral of L of t is going to just be L of t, right? I want to know when this happens. When is S prime of t minus L of t equal to 0? In terms of time, it may be easier because if you tell your calculator to be calculating the derivative at a whole bunch of places from 0 to 12, it may be simpler to just go ahead and take this derivative at this point. I've avoided it so far, but it may be, do you see what I'm saying? It may be worthwhile to go ahead and take that derivative. So that's going to be 2t cubed minus 48t squared plus 288t minus L of t is equal to 0. So I'm going to go into my calculator. You guys do know how to turn these off, right? So that they don't graph. Just move back over the equal sign and go, yeah, stop graphing that. All right, so I want 2x cubed minus 48x squared plus 288x minus y2. You know what, rather than try and copy and paste that or anything, which doesn't work particularly well on this, I'm just going to go minus y2. And I want to know whether that's equal to 0 between t is 0 and t is 12. And my y min right now just happens to be set at -4 and 4. That should be fine. Worried there for a moment, don't you? You're like, it's never going to be 0. There's only one 0. Okay? And so we'll find that. Find the 0. It's somewhere between 1, 2, 3, 4, 5, and 6. 5.63. When you're within 1/10, you did pretty well. So 5.545. Was it 545? Okay. Now, to justify your answer, the rubric is only going to show one way to justify your answer. But there's actually two different ways that you could justify your answer. One way is to do the candidates test because this is a closed interval. Notice it's closed at 0 and 12. And we know that at time 0, there were no people in the store. And I know at times 12, there were 196 people in the store. So at time 5.545, the number of people in the store is going to be S of 5.545 minus the integral from 0 to 5.545. There's too many of the same numbers in this. Of L of t. And the nice thing is I already did that on my calculator with a 12 in it. I just need to change the 12 to 5.545. So I'm going to go up and get that. Change the 12 to 5.545. 5.545. Bada boom, bada bing. It's 13.61833. I hate that I can't remember. 1361,833. So this would be justification enough. 545 hours. You could also justify it by using, remember we did the lone candidate test? It's the only critical point on the open interval from 0 to 12. And at this point, the derivative changed from positive to negative, making it a local maximum. And since it's the only critical point, and it's a local maximum, it must be where the absolute maximum occurs. Okay, this is good review for stuff. This is part of why I like doing these later in the year. Some people do it much earlier. And you can see they used a candidates test, which is probably the easiest. I only use the lone candidate test when I have to. All that good stuff. All right, let's look at, I think I mentioned earlier, you could have a death rate and a birth rate. That's what we have here. So the penguin population on an island is modeled by the differentiable function p of time t, where p of t is the number of penguins and t is measured in years between 0 and 40. There are 100,000 penguins on the island at t is equal to 0, and it gives you a birth rate and a death rate for the penguins. So what is the rate of change in the penguin population on the island at t is equal to 0? Well, so the change, and I'll call that C of t, what's that going to be equal to? I don't, just in general, you don't have to give me all the numbers.
The integral of E of t.
This is the rate.
Oh, I see. Oh.
So we want the rate of change. I'm sorry, I didn't say rate. The rate of change, C of t, is going to be what? I asked it wrong. I asked for the change. So what is the rate of change going to be?
B of t minus d of t?
Yeah, that's exactly right. The rate at which they're born minus the rate at which they die. So C of 0 will be B of 0 minus D of 0, which is 750 penguins per year. They usually ask you a question like that to kind of make sure you're thinking the right way about this. It's called leading you into the question. So to the nearest whole number, what is the penguin population on the island at t is equal to 40? All right. So the number of penguins is going to be equal to what you started with, 100,000 plus the integral from 0 to 40 of b of t minus d of t, right? Because the integral of the rate of change of something gives you the amount of change. So again, that would be one where I would put that into my calculator as, I'd probably put it in as y1 and y2. In the interest of time, I'm just going to move down to this and go, oh, look, it's 133,058 penguins. Is that 133? No. Yeah, 133,058. And if you'll notice on the rubric, they're looking for the limits, they're looking for the integrand, they're looking for the answer, and that's it. I mean, this is a calculator active problem. All right, to the nearest whole number, what is the average rate of change of the penguin population? Okie dokie. So again, this starts driving people crazy. So if I let P of t be equal to the number of penguins at time t, the average rate of change would be equal to P of 40 minus P of 0 over 40. Well, we know how many penguins are on the island at time 40. We know how many are on there at time 0. This is actually a really easy problem. It's 33,058 over 40. Penguins per year. Can you put that into your calculator? Yeah. Do you need to? No. Let's see what they did. Yeah. Notice you can do it either way. Because the integral of the rate of change is going to give you So this is the average change over that, and this is the average rate of change. It's the same thing. You can think about it either way, and sometimes this gums up people's thinking, right? But they really are the same, because this part right here is going to be B of 40 minus D of 40 minus our population at time 0, right? Here we're doing, this is going to give me my population at time 40 minus my population at time 0. It's the change in the population. All right. And then part D, to the nearest whole number, find the absolute minimum penguin population and the absolute maximum penguin population on the island between 0 and 40. Show the analysis that leads to your answers. Okay, very similar to the last one. We know the population at time 0. We know the population at time 40. They've already asked us those. They don't always ask for both of those. So sometimes you have to find one of them. So we just need to find a place where B of t minus D of t is equal to 0. Okay? So B of t minus D of t is equal to 0 implies that t is equal to, and again, in the interest of time, it's 34.657 something. So then if we're doing this by the candidates test, we need to find the number of penguins at t is equal to 3, 4, 6, 5, 7, yada, yada, yada. And it turns out that that is 139,166. Looks like 0.6 repeating. Which is greater than it was at time 40. So again, this is the candidates test. You test the endpoints, you test all of the critical points. Did it ask for the minimum and the maximum? Oh, it asked for both. So the absolute minimum is going to be 100,000. The absolute maximum is going to be 139,167. Okay, any questions about that? Okay, I wanted to show you one where they gave you rates for both the in and the out, and another one where they gave you a straight up, this is how many, and a rate for the other one, because they switch back and forth. Almost always one of them will be a rate at least. Sometimes they're both rates, sometimes not. That worked out well.